Hello everyone, my name is Mohammed Al-Hajri and in this video my friend Mohammed Nazal, Mahdi Mirza, Jarrah Al-Qarawi and I are going to talk about our capstone project at AUM, which is the conversion of municipal solid waste to synthesis gas by using plasma gasification technique. Nowadays, the world is facing a huge crisis of dealing with the increase of the municipal solid waste due to the rapid urbanization. On the other hand, the main source of energy used is considered as non-renewable energy, such as a fossil fuel. It's worth noting that the accumulation of the municipal solid waste is increasing in Kuwait. This rapid increase of MSW is occurring due to several reasons, and one of them is the increase in the population. In Kuwait, the main component of the municipal solid waste per sector are 68% household, 17% agricultural, and 15% commercial wastes. Normally, MSW contribute to tons of emissions of CO2 and methane. The predicted amount of MSW in Kuwait is 2.532 million tons per year in 2021. In addition, it will be almost doubled in 2050. Unfortunately, Kuwait relies only on fossil fuel as its primary energy resource. Kuwait is facing two main problems, which are the accumulation of municipal solid waste and the shortage of primary resources. It will be an intelligent procedure to solve these problems by converting MSW into a value. Now Mahdi will talk about the pre-exist solutions and the proposed solution.
So, as it's evident, we have a lot of pre-existing solutions, which are landfilling, biological, hydrothermal, and thermochemical techniques. Regarding the landfilling technique, this technique is considered the most used method in several countries for reducing municipal solid waste accumulation. The landfill waste disposal method can be defined as the burial of the MSW in a particular location. The positive aspect of this method is that it is a smooth process. The negatives of this process are site selections. It causes significant loss to the circular economy, and landfill isolation cells are sometimes not dependable, and it will lead to leakage. The second pre-existing solution is biological techniques. These techniques focus on treating organic waste in the MSW. The challenges, which are at the same time considered disadvantages of the biological technologies, are time consuming, require a large area, and inefficient for hazardous waste. The third solution, hydrothermal techniques. The hydrothermal techniques can be defined as waste elimination processes in which the components of MSW are exposed to the movement of water at certain temperatures. The drawbacks of these techniques are require high operational costs and not being operationally safe. For the last pre-existing solution, the thermochemical techniques are waste treatment that depends on heat in their process. There are some negatives and positives to these techniques. Concerning the environment, this technique is environmentally safe because it produces valuable products that are not harmful to the environment, such as syngas. The disadvantages of these techniques is that it requires high operational costs. After applying a lot of analysis and research, it was found that the best and the most attractive waste management treatment is the plasma gasification technique. In this technique, four major stages should be conducted, which are waste handling, the plasma gasifier, gas cleaning, and then conversion unit processes. This technique converts MSW into both profitable and valuable product, which is syngas. The advantages of this technique are it helped to accomplish zero waste accumulation, save the environment, and last but not least, produce sustainable fuels. And now the next slide with my friend Hamid Nazal.
So now, to sum up the main objectives of this project, we can say that we have four major objectives, which are: first, we have to conduct a literature review concerning the conversion of MSW into value by using plasma gasification technique. This needs to be done because we have to understand the concept and principle of plasma gasification with all the updated information about it. Then we may develop new solutions for some constraints. The second objective is to perform a comparison between plasma gasification technique with many others waste treatment techniques such as landfilling and incineration. This objective is essential since the comparison will allow us to identify the most effective waste treatment technique. The third, now that we have a sufficient amount of understanding of the process, we should propose a block flow diagram and then develop it with more process operation details in form of a process flow diagram. Finally, after targeting a specific amount of MSW in Kuwait that needs to be treated by using the plasma gasification plant, we can then perform material balance around the planet to ensure that the law of conservation of mass is met. This figure demonstrates the block flow diagram for the plasma gasification process. As previously mentioned, it consists of four main stages. As you can see, the first stage is the waste handling, which contains the following: waste collection, sorting, crushing, drying, and grinding. Then the second stage starts with the third and grinded MSW entering the plasma gasifier, where the reaction will take place to produce two valuable products, which are the syngas from the top and the slug from bottom. Then the syngas will be cooled down by using a heat exchanger before the beginning of the third stage, which is the gas cleaning stage. Finally, the last stage, which is the conversion process, is going to convert the syngas to energy. This figure demonstrates the process flow diagram for the plasma gasification plant, and it contains all the details of the process parameters. Now, I'm going to leave you with Mohammed Al-Hajri to explain to you the material balance calculations.
The material balance is the exact accounting of all materials that enters, leaves, accumulates, or depleted within a given period of operation across an imaginary boundary of a process or a part of the process. In addition, in material balance, the law of conservation of mass is considered to be the main principle. First of all, many assumptions will be clearly stated to have a precise result and for the ease of calculation. Some of the main assumptions are the process is adiabatic and the process is at a steady state. Moreover, the capacity of Unit 100 is 300 ton municipal solid waste per day. Finally, it will be found that the sum of the inlet streams is exactly equal to the outlet streams, which means that we applied the law of conservation of mass. Now Jarrah will talk about the conclusions and the future plans.
In conclusion, the accumulation of MSW is increasing in Kuwait day by day, and Kuwait relies only on fossil fuel as its primary energy resource. As a result, there must be serious conduct to reduce the accumulation of MSW and produce clean energy. Therefore, worldwide, MSW disposal can be handled by several techniques, and some of these techniques can be considered being waste to value processes. Based on the literature review, it has been found that the best technique to be used as a waste to value process is plasma gasification. In order to accomplish this technique, there are four major stages should be conducted to which are the following: waste handling, plasma gasifier, gas cleaning, and then conversion of unit processes. The outputs of the gasifier are slug and raw syngas. The block flow diagram and the process flow diagram were introduced for the plasma gasification plants. Finally, overall material balance was done to verify of the conservation of mass law. There are some plans set to be applied in the future, which are performing energy balance for each unit, designing all equipment in Unit 100, defining constraint and optimization goals, considering safety, ethics, and environmental aspects of the process, estimating the capital cost of the planet. Thank you for watching.